Hello everyone, my name is Amol More and welcome to our channel Solution to Black Book. Today we are going to understand and learn a very important JEE advanced concept which is called as Beggar's method for distribution of objects. It is popularly known as Beggar's method, but it is also called as partition method. As we move along the lecture, you will understand why is it called as partition method. Now, a very simple example for Beggar's method could be, suppose you have these two beggars, okay, and here you are, okay, and you have four 1 rupee coins. All are identical in shape and size, and you want to give these four 1 rupee coins to these two beggars. Now, how would you give this to all four 1 rupee coins to these beggars? So you could do this. You could give 0 coins to the first beggar and all 4 coins to the second beggar, 1 coin to the first beggar and 3 coins to the second beggar, 2 coins to the first beggar and 2 coins to the other beggar, 3 coins to the first beggar and 1 coin to the other beggar, and 4 coins to the first beggar and 0 coins to the other beggar. So see, all coins are identical in shape and size, and there were total how many ways? 1, 2, 3, 4, 5. So there were in total 5 ways to distribute these 4 coins to these two beggars, right? Okay, so that is actually the concept behind such questions in which there are two beggars and you have to distribute four things amongst two beggars, but always making such combinations would be a lot difficult for us, right? So we will do one thing. Let us say we have a table, and on that table I keep these four 1 rupee coins which are identical in shape and size. Okay, then I get a partition. Let me say that partition is purple colored. I put the first partition here. Okay, so what will happen? Let me say the left coins to the partition are given to the first beggar and the right coins are given to the second beggar. So this way the first beggar will get how many coins? 1 coin, and the second beggar will get how many coins? 3 coins. Okay, now let me say I change this partition. Okay, now the partition is over here. Now the first beggar will get, the first beggar will get 2 coins and the second beggar will get 2 coins. So that is one way. Okay, now suppose if the partition is here, now the first beggar will get 3 coins and the second beggar will get 1 coin. Now suppose if the partition is here, now the first beggar will get no coins because there is literally nothing on the left, and the second beggar will get all the coins. So that is one way. Okay, if the partition is over here, then the first beggar will get all 4 coins and there is nothing to the right of the partition, hence the second beggar will get no coins. Okay, so this way we can distribute, right? So we saw that this particular partition could go anywhere. There were many possibilities, right? So there were many possibilities for that partition. So let me call that partition as an object. So there are total how many objects? 1, 2, 3, 4, 5. There are in total 5 objects which can be jumbled, shuffled along themselves. So I can say total is 5 factorial because I can shuffle them along with one another. But then I observed that all these 4 coins are identical in shape and size. So even if they are shuffled along one another, amongst one another, there will be no permutations made. Hence we have to divide by 4 factorial because there is repetition of 4 1 coins. And this particular partition is just 1, so that is 1 factorial. So if you solve this, this will be 5 into 4 factorial upon 4 factorial. 4 factorial got cancelled and the answer is 5. Okay, now you will say this was a very simple sum. Now what am I going to do is, suppose the same two beggars come to you. The beggars came to you because you give them money, so they come again the other day. And this is you, because you did some charity on another day. Now you have more number of rupee. Now you have 5 rupee. Okay, all are 1 rupee coins, and you have to distribute them to these two beggars. It is your will that if you want to give any amount of rupee to the first beggar or not. If you want to give, you will give, otherwise all the 1 rupee coin you will give to the second beggar, and vice versa. So again the same technique can be applied. So let me apply the same technique again. So what will I do? I have 1 rupee coins placed on the table. These are 5 coins. Now there are 2 beggars, so I will need one partition. So let this be the partition. Now total objects are how many? 1, 2, 3, 4, 5, 6. So 6 factorial. But 1 rupee coins are 1, 2, 3, 4, 5. So that will be divided by 5 factorial upon 1 factorial. So this will just be 6 into 5 factorial upon 5 factorial, and 5 factorial got cancelled. So the answer is 6. I will even check you with the answer. 0, 0, 5, 1, 4, 2, 3, 3, 2, 4, 1 and 5, 0. Just check how many number of combinations are possible. 1, 2, 3, 4, 5, 6. And our answer was even 6. But what happened on the third day? On the third day, these two beggars were very happy that you are doing some charity. So these two beggars came along with their friend. 1, 2, 3. Now there are 3 beggars, and this is you, right? And now you have 1, 2, 3, 4, 5, 6 1 rupee coin, and you have to distribute them amongst these beggars. What are you going to do? So if you want to give some amount of money to the third beggar, you will give or you will not. Same will be happening with second, and same will be happening with the first. So it is your will that for a particular beggar you want to give some money or not. Okay, now how to do such kind of questions? Similarly, you will make 6 1 rupee coins on the table. So let me place those 6 1 rupee coins on the table, identical in shape and size, though my diagram does not look identical. Okay, and there are 3 beggars. So for 3 beggars you will need 2 partitions. Now to the left, this is for the first beggar, this is for the second beggar, and this is for the third beggar. And similarly, if you rotate, if you shuffle the partitions, you are going to get different combinations, right? Now the first beggar is getting how many rupees? 2 rupees. Second beggar is getting 3 rupees, and the third beggar is getting 1 rupee. If I place this partition over here, then the first beggar is getting anda, nothing. Second beggar is getting 5 rupee, and the third beggar is getting 1 rupee. So total how many objects are there? 1, 2, 3, 4, 5, 6, 7, 8. There are total 8 objects. So they can be shuffled in 8 factorial ways or rearranged in 8 factorial ways. But 6 1 rupee coins are very much identical in shape. Hence I will divide by 6 factorial. But these two partitions are identical. They are same. So even if they are reshuffled amongst themselves, it will not make a new arrangement. Hence I will divide by 2 factorial. Now after I solve this, I will get 8 into 7 into 6 factorial upon 6 factorial into 2 factorial. 6 factorial got cancelled. 8 into 7, 56 by 2, 28 ways. So there are 28 ways in which you can allot these 6 1 rupee coins to these 3 beggars, right? Now I am not going to show you all those 28 combinations just like I showed you this, because it will take hell a lot of time, and I will definitely surely miss some or the other combinations. Okay, you can try that at your own risk. Okay, now let us move ahead. We understood some particular formula. Now I want to generalize it. Now suppose there are n 1 rupee coins. How many coins? N 1 rupee coins. And there are how many beggars? So first of all, I will write it down over here. N identical 1 rupee coins. N identical 1 rupee coins. Right? N identical 1 rupee coins. And there are, let us say, R beggars. There are R beggars. Okay, so for R beggars, how many partitions would be required? So let us have a look. So if you see, there were two beggars. First of all, there were two beggars. So one partition was required. Then there were three beggars. So there were, how many partitions were required? Two partitions were required. Now there are R beggars. So there will be R minus 1 partitions. There will be how many partitions? R minus 1 partitions, because the number of beggars will be R, so the partitions will be R minus 1 will be required. So such objects R minus 1 partition makers will be required. Okay, I will call this R minus 1 partition makers will be required. Okay, now let us say there are total how many objects? N coins plus R minus 1 partition makers. So these many objects are there. So this will be N plus R minus 1 factorial. How many total objects were there? N coins and R minus 1 partition makers. Add them, you will get the total number of objects. N plus R minus 1 factorial. But N coins are identical. Hence their rearrangement won't matter much. Hence I will divide by N factorial. But R minus 1 partition makers are also identical. Hence I will divide by R minus 1 factorial. Very good. Now just have a look at it. I will write it again. So this will be N plus R minus 1 factorial upon what do you call it? N factorial and R minus 1 factorial. Okay, now if you have a proper look at it, this can be written as N plus R minus 1. Okay, and see this N if you see, and this R minus 1 if you see, they are two parts. They are two parts of it, N factorial and R minus 1 factorial. So basically if you call this P and if you call this Q, this will be P plus Q factorial upon P factorial into Q factorial, right? So this can be written as N plus R minus 1 CR minus 1. This is the combination formula. If you have any doubt, I will show you how does it work. N plus R minus 1 factorial upon what do you have is N, what do you have? R minus 1 factorial, right? And then N plus R minus 1 minus R minus 1 factorial. This is how you do it, right? N plus R minus 1 factorial, then R minus 1 factorial, and then the subtraction of both of them over here. So this will be N plus R minus 1 factorial. This will be R minus 1 factorial. If you observe carefully, R is getting cancelled and even minus 1 and minus 1 is getting cancelled. So all you have is N factorial. So if you see, our formula which was formed is exactly the same. Hence the distribution of objects can be written as this: N plus R minus 1 CR minus 1. So what do we have? If there are N identical objects, N identical objects to be distributed amongst R people such that anyone can get any number of objects. Any number of objects. This is very important. It means what? A person can get 0 objects also. See, I have shown you in the first example, the beggar 1 got 0 rupees and beggar 2 got 4 rupees. So over here, any object, any person can get any number of objects. Then the distribution can be done is, the distribution can be done in, okay, distribution can be done in how many ways? So N plus R minus 1 CR minus 1 ways. Okay, this is our formula. I will also tell you one more thing. There is a formula for NCR in which NCR can be written as NCN minus R, right? This everyone knows. If I apply the same formula to this particular thing, what will I get? N plus R minus 1 CR minus 1. So N plus R minus 1 C, you have to subtract this from this. So I will show you the subtraction. n plus r minus 1 minus r plus 1. So observe carefully, r got cancelled and even 1 got cancelled. So basically we are remained with n. So basically n plus r minus 1 c r minus 1 has been turned into n plus r minus 1 c n. So either you use this formula or you use this formula, your answer will be the same, right? Okay, now let us move ahead. I will give you a question. Suppose I am a father. Okay, I am writing my will. I have a property of 8 rupees. Okay, 8 rupees. You can consider that as 8 lakh. Okay, 8 rupees. And I have 3 sons. Okay, in how many ways I can distribute the property? In how many ways I can distribute the property? Okay, in how many ways I can distribute the property? Very simple, right? Okay, now let us move. In how many ways I can distribute the property? This is the sum. Now let me say my first son is x, second son is y, and third son is z. Now I am going to give them some money. So first son will get some money, second son will get some money, and third son will get some money. If some son does not treat me well, then I might not give him any money, like zero money. Okay? So I would say x plus y plus z, the amount received by them, x plus y plus z, is nothing but 8 rupees. So you can see that x plus y plus z equal to n, right? R is the number of beggars, so my sons are nothing but beggars. Okay, and n is the amount of objects that is to be distributed. So I can apply the same trick, which is n plus r minus 1 cr minus 1 or n plus r minus 1 cn. So simply I would say n is equal to 8, r is equal to 3. I will do it by both methods so that you will understand. So n plus r minus 1 c r minus 1. This will be 8 plus 3 minus 1 c 3 minus 1. So this will be 12. 12 minus 1 11. 11 c 2. So it will be 11 into 10 upon 2 into 1, which is nothing but 55 ways. So there are total 55 ways in which I can distribute my property. The same formula can be written as which I told you earlier, n plus r minus 1 cl. So 8 plus 3 minus 1 c 8. So 11, 8 plus 3 11. Oh, I made a mistake. Very sorry. 8 plus 3 is 11 and 11 minus 1 is 10. 10 c2. So 10 into 9 upon 2 into 1. So this will be 45 ways, right? 8 plus 3 11, 11 minus 1 10. Okay. The same trick will apply here. 8 plus 3 11, 11 minus 1 10, 10 c8. But definitely 10 c8 can be solved like this: 10 factorial, 8 factorial, 2 factorial, right? And again this will be 10 into 9 upon 2 into 1, which is nothing but 45 ways. So either you use this formula or this formula, you are getting the same thing. So this was part 1 for Beggar's method, in which what we had learnt is that if there are n identical objects and they are to be distributed amongst r people, then that can be done in n plus r minus 1 cr minus 1, provided that any of the person can get any number of objects. So such kind of concept can be applied to this particular question. X plus y plus z is equal to 15, where x, y, z belong to whole number. Whole number means number of solutions we have to find out, and whole number means x, y, z can be 0, right? It means this: x greater than equal to 0, y greater than equal to 0, z greater than equal to 0. And we need to find out the number of solutions for such question. So very simply we will say n is equal to 15 and r is equal to 3. And one thing you have to remember, that x, y, z, anyone amongst them can be 0, as stated by me. That is why I have written whole numbers. So what will be the formula? n plus r minus 1 c r minus 1. So 15 plus 3 minus 1 c 3 minus 1. So that will be 18 minus 1 17, 17 c 2, 17 into 16 upon 2 into 1 is our answer. Very simple. So 2 8. So 17 8 it is what we have to do. So it will be 126, I guess. Let me check. 80 and 56. Oh sorry, 80 and 56, 136. Okay, so that can be done in 136 ways, right? So this is how this kind of sums are done. So this was for lecture 1 of Beggar's method. This is very important for difficult means level question, and it is an advanced level question. Okay, now there were partitions. See, there were partition makers, hence this method is also called as partition method for distribution of object. I hope you liked this video. If you liked this video, please hit the like button, and there is a subscribe button very close to the video, just below the video. Please hit that subscribe button, and also press the bell icon to get the continued notifications from our channel. Okay, I will come up with lecture number 2 very soon for this Beggar's method, and we will understand that in very much detail. So for today the lecture ends, and this is Amol More saying bye bye to you.